Okay, in this video, I will illustrate to you how to solve for marginal analysis using normal distribution. This is for a situation where you will be making a decision whether you want to stock additional unit or additional whatever unit of measurement you're using of items. And this would be for items that has no more sellable value once you pass a certain point. For example, if we've used the example of donut. Now we will use the example of newspaper. So we will do this analysis, stocking analysis for a single inventory model when it is normally distributed. We'll use the example of Chicago Tribune newspaper at Joe's newsstand. It is normally distributed and with an average of 60 papers per day with a standard deviation of 10 papers, so it's normally distributed, with a marginal loss of 20 cents and a marginal profit of 30 cents. The question is, what daily stocking policy should Joe follow? So I'm going to let you study that section. It's in the book. Go ahead and study it. But I will show you how to solve this with POM QM. Okay. Bear with me. I will stop sharing. Where is my POM QM? Okay, so this is my POM QM. All right. So what we need to do is I need to go to inventory. Actually, I'm gonna start new. So I'm gonna click new and I'll go for single point inventory with normal distribution. Okay. So the question is, we are gonna use marginal probability, marginal profit and loss. We click on that and then we click OK. The first question is, what is the marginal profit per unit? The marginal profit per unit here, it said, yeah, marginal profit per unit is 30 cents, 0.30. Marginal cost or loss here is 0.20, 0.20. Okay, and the mean of newspaper sales is 60 per day with a standard deviation of 10 papers. Then based on that, we click solve. It gives us the answer. Yeah, the cutoff point is 40%. Cutoff point is 40%. And the optimal order quantity is 63 papers. So in other words, it's saying that the probability of not being able to sell more than 63 paper is 40%. The probability of selling 63 paper and lesser is 60%. Okay, is 60%. Yeah, so 40% is the probability of not being able to sell the 63rd newspaper or 62nd newspaper. The probability of being able to sell the 62nd newspaper is 60%. So the optimal newspaper to sell is 63. If Joe's newspaper stand order more than 62 or stock more than 62 newspapers, say 63, then there is a 40% probability that he will not be able to sell the 63rd paper. Okay, so that is the optimal stocking stocking policy is 63 paper. Yeah. We can change the story. What if Chicago Sun-Times, the They also stock Chicago Sun-Times, and the marginal loss is 40 cents. So let's edit the data. Marginal profit is 10 cents, 0.10, 0.10, and the marginal loss is 40 cents. So 0.40. And the mean of selling Chicago Sun-Times, the mean is 100 copies every day with a standard deviation of 10 papers. Okay. Then we solve for it. And we find that the cutoff point is 80%. Joe should order 91 copies of Sun-Times every day. Yeah, every day. Because the probability of being able to sell up to 91 newspaper is about 80%. Yeah. Okay, so that would be the optimal stocking point. So I think I have shown you how to do a single inventory model using discrete probability and also using normal distribution. After that, if you study the textbook, after that we enter another model which is called ABC analysis. It is self-explanatory. I ask you to read it. It's simple. Yeah, it's basically classifying the types of item you're carrying into some that is most sensitive, some that is most important to the least important. The most important ones, you need to use a sophisticated quantitative inventory control model. The second group is somewhat important. So in some cases you want to do that. But the third group, you know, it has a very small dollar value, about 10% of total inventory cost. The inventory items might be large, but the value is small. In that case, you may not want to use a sophisticated quantitative inventory control techniques. For the items that have high dollar value, even though the inventory item is only 10% of the total item, but if the dollar value is huge, 70%, then you would like to use a quantitative inventory control techniques. So go ahead and read that. It explains in more deeper. Then I need you to read the case for material requirement planning. Yeah, please read MRP. What is MRP? It gives you a pretty good explanation of what that is. So what I've done is I've recorded some tutorial on how to use POM-QM to solve some of the inventory models. Thank you.